Thank you. GM. Uh, my name is Vikas. Like my colleague said, I work with the NEAR Foundation. So NEAR Foundation started almost 3 years ago as a layer one general purpose blockchain. And the vision of creating NEAR was to solve the problems that we saw with the first generation of blockchains like uh, congestion issues, security, and gas fees. Over the years, a lot of the first generation blockchains, Ethereums and others, a lot of L2s were built on top of them, like as we know, the Polygons, the Arbitrums and others on the EVM world. Near being a non-EVM blockchain protocol, never had these problems. You know, the scalability, security, because it's built on Rust, it always has sharding by design called Nightshade. So last almost a year, Near has been building something that is called as blockchain operating system. And that's something that I work with at the Near Foundation currently, trying to propagate the concept of interoperability in the blockchain world, while also talk about the Near blockchain operating system. So today's talk will generally be covered around blockchain interoperability, and that will lay the foundation to take us to the end or at the conclusion about how is Near Foundation solving the problem of blockchain interoperability. I think we have 28 odd minutes. We'll try to finish the talk before that and maybe keep a couple of minutes for any questions. So let's kick it off. So blockchain interoperability, the most important concept of any interoperable solution is how do you exchange information, data, or assets across different systems, right? Whether it is Web 2 or Web 3, it doesn't matter. So it's the same in the blockchain world. A lot of these blockchains were built or designed in a very fragmented way. So you could transact or share assets only within the same ecosystem. Like if you're in Cosmos, you can only share it within the Cosmos ecosystem. But the moment you wanted to move out of one blockchain to the other, there were issues like bridges and others, which created a lot of security issues, user experience, and gas fees, among others. So we are going to cover those topics. How are some of the blockchains of today, the second or the third generation as well, like people call it, are solving some of these problems. So these are some of the topics, the introduction and background about blockchain interoperability. What is it? The problem statement and the challenges that exist today, and what are the different approaches to solving this interoperability challenge in blockchain? And what are the different cross-chain protocols, like the top 4, top 5 that exist currently in the world, and how are they trying to solve this problem? And what are the benefits that we get out of this, some future outlook, and where do we start? Where I'm also going to talk a little bit about the Near blockchain operating system. Just some introduction background. Blockchain interoperability, the whole idea is how do you seamlessly transfer information between two blockchains or two blockchain networks. So when I say transfer information, information can be in the form of data, it can be in the form of assets, and the assets could be images, video, or even tokens, as we see in the blockchain world. And another very important aspect is what are the different consensus protocols that exist between these blockchains. So some blockchains use the modern ones, proof of stake. Some others use proof of stake of authority, BFTs, PBFTs, and others. So that's also something that we'll talk a little later. What are the challenges that those things bring? And then the background, right? So a lot of these blockchains were designed back in the day to only operate in their own ecosystem. A good example is, like I said, when Bitcoin started, 2008 and 9, the whole idea was only to transfer assets or money in that case, right, the digital money. And then came Ethereum, which added the smart contract layer. So with smart contract layer, we got computation power to the blockchain networks. But within Ethereum, we had problems like huge gas fees where we paid $200 up to $250 for one transaction. but also this transaction times and finality was a very big problem. It took hours sometimes. And after Ethereum, we saw a lot of the chains that tried to build on top of it, like building polygons of the world or Solanas and others. So these chains, they started to solve the congestion issues, but also some performance issues. Some of them were very cheap in gas fees. And then we had roll-ups and L2s and L3s also, as some of them call it. A lot of these solutions were always built with the premise that you are always going to work within your blockchain ecosystem, like within your own network, and not interact with the other networks. A couple of them tried an approach to interoperability, and that's something we'll also see later on. Yeah, in terms of importance, again, like I said, apart from moving information across systems, the other very important aspect, like we can see on the slide, is how do you improve scalability, right? Like some blockchains are designed for security, others are designed for low gas fees, while the third could be designed for scalability. So we'll also see how those things are being addressed in the current situation. So a lot of these blockchains, like I said, somebody has a very different transaction scheme, very different data structure. How do you consume data? How do you process them? And how do you spit out data that can be consumed by other systems? A lot of them have challenges with on-chain and off-chain data sharing and management. And then a lot of these things are so fragmented that you cannot move out a lot of data from one chain to the other and start using it seamlessly. That's the challenge that we see with a lot of systems. So subgraph is one technology that tried to solve this problem by indexing the whole blocks, the transactions together, so that it can be transferred and moved to the other chain and be consumed very seamlessly. But again, in that we still see challenges such as the data structures, the data formats, and the support that we get out of it. And a lot of these blockchains also have this challenge, like some blockchains are designed for IoT, some blockchains are designed only for scalability, the others are designed only for low gas fees. But there's no wholesome or a utopian blockchain that exists today, and it's also a bit difficult, that solves the blockchain trilemma, as we all know, right? In terms of cost, speed, performance, among others. And all of these things have also created duplication of efforts. What does that mean? That means that one blockchain is trying to solve the gas fees problem, while the other blockchain is trying to solve the same problem. The third or the fourth is trying to solve the same problem in a different way. So all the effort that the industry could put into building a very efficient, gas-efficient solution was put into building parallel solutions and duplication of efforts. A lot of blockchains were built for design to scale. A lot of blockchains were built for lower gas fees, among others. So, and we see like at least 3 or 4 of these blockchains are trying to do the same thing instead of trying to take this problem as an industry problem and solve it together. So what are the different approach to interoperability? So there are a couple of them. So there is a standard-based approach, and then there's these side chains, parachains, roll-ups kind of an approach. So in the standards-based interoperability approach, we have seen some of these blockchains like Polkadot, Avalanche, Cosmos, the wormhole, but also Near has blockchain operating system. They are trying to bring standardization in the way you feed data to the system, the way the data is stored, the way data can be uploaded to the other blockchain, and also the way it can be consumed and then presented to the user or to other systems in the form of events. So that's one approach, trying to standardize the whole input-output process of the system. And then exchange of data. So we have seen with a lot of these bridges, right, when you transfer assets or when you transfer information, we have had security issues. So that's also something that has to be addressed in terms of how do you exchange data between these systems seamlessly. Either you do it in a standardized format that the whole world follows a certain format, or you set up what is called as extract, transform, load engines between these two systems so that they can consume, transform it, and load it and upload it into the system that understands the language. And then there are also challenges that are not mentioned on the slide, like naming conventions, right, nomenclature, or ontology of these systems. So that's a very big topic for some other day. But what it means is how do you name these different solutions, the JSON objects, and the files, and the input and output of these different chains. So some of the example, like I said, so we have this wormhole near blockchain operating system. We see polka dots of the world. We have one chain among others. Hyperledger is also trying to do quite a lot of things in interoperability, especially with the EVM stack. So we'll also see some of those examples and also try to dive deep a little bit on how Near is trying to solve this problem later on. Side chains, so we'll also see in the next slide the different approach. So in terms of side chain, there are different approaches, like there are plasma, shards, and side chains, where you do not send all your transactions to the main chain. You process the transaction in a silo which is still connected to the main chain, or the main chain is divided into a mirrored image of the entire stack, and then you process the transaction at the end of the day, or after 4 hours, or at a certain point of time, so that the performance and other challenges like sharing the data between systems can still be transformed and uploaded into a different system seamlessly. So tokens, so there's also this concept of pegging your tokens, right? So you can use your tokens from one chain and peg them against as an asset to the other chain and still use it like wrapped USDCs or staked USDCs, and it can be used into different chains. But again, it also impacts the user experience a lot, while also exposing security issues, right? Because when you wrap them through a bridge, transfer it to other chain. There's a risk in bridges. As we have seen, there are a lot of hacks because the token literally sits there until it is moved to the chain. It doesn't happen in real time. While for the user, you always have to unwrap between these two chains, move move from one wallet to the other, and keep on waiting until the whole transaction is complete. So in order to do one full transaction between two chains, you have to do 6 different transactions across 2 or 3 networks. So this is an interesting slide. So like I said, there are 3 different approach. Maybe there are more. This is a slide, an old slide from 2019 by Whitelake. So people have been talking about this topic for almost 4 years and also doing quite a lot of effort and research in this area. So there is this shards, plasmas, and side chains. So shards is the premise on which the Near blockchain, the Near protocol was designed. And Ethereum, as we all saw last year, right? Ethereum launched their own sharding scheme where you can, create multiple replicas or a separate set of chain that runs by itself. And it has a tight coupling with the main chain. So whenever you want, you can also, still share the data with the main chain while the shard keeps running independently by itself, providing a lot of scalability to the main chain. So that really solves the problem of scalability, but also the problem of security, because the shards works still with the main chain and doesn't have to go through the risks of data sharing between chains. Plasmas is like it's a side chain, and it basically is a chain that runs very similar to shard. But if there's something that happens to the plasma, you can always cut off the connection from the main chain and spin up a new plasma. You can still roll it up to the main chain when you want, but it also is not completely connected like what we saw with the shard, because it's not a mirror image of the main chain. So it still has a lot of dependency in terms of performance and source of truth, as well as the finality to the main chain. And the side chains are very similar to what we saw with the polygons of the world and the polka dots of the world, where you have a very loosely coupled side chain with the layer 1, which runs parallelly to the main chain. A lot of these transactions are happening by itself, so you can distribute your transactions to these side chains, and then you decide when do you want to bring those transactions to the main chain for finality. So it improves the performance, also reduces gas fees, storage issues, among others that we see with scalability in the blockchain world. So yeah, some of the benefits and future outlook. So like we saw, right, it's a pattern with not only with blockchain systems, but also with the Web 2 or Web 1 of our technical world. So a lot of these things have 2 or at least 3 dimensions. One is scalability. You cannot scale if the interoperability is not put into place. The second is efficiency. It's not efficient enough, because you have to keep processing the same transaction for for minutes, sometimes hours, so it's not efficient. It's also very expensive in terms of gas fees, or it's also very, it also adversely affects the user experience. So the user, like I said, has to keep moving across the stack, something that I'll also explain at the end of the talk. If, with an example, where a user has to keep moving, from the wallets to the smart contract to the finality layer across chains if they want to interact between two blockchains. So, yeah, there are a lot of innovation in industry collaborations happening on this area. Polkadot is doing quite a lot of collaboration in terms of their side chains, but also working with other chains to create, to solve the problem of interoperability. But Polkadot by itself with one or two other chain will not solve the problem. There are at least 150 plus blockchain protocols in the world today. So there has to be a bigger and larger effort to try to standardize and create a common layer between these systems across the stack, from the front end to the middleware to the finality layer, and even at the validator level where there are a lot of these servers or nodes running to solve the problem of proof of stake. And then one chain is another one that's working with 12 different blockchains. That's a very nice initiative. And Wormhole, like I mentioned earlier, is also working with 14 different chains. And Near protocol is taking a different approach. So all of these chains started their interoperability approach, and they kept on adding one chain after the other. Whereas at Near, we created what is called as a blockchain operating system, a wrapper on top of the Near L1 chain, from where you can communicate to the chain using the blockchain operating protocol decentralized front ends, which can be built by anybody, very open source in nature, and then communicate with the smart contract of any chain that can be deployed using the gateway. And after you have communicated with the gateway, you can also choose which chain you want to write your finality depending upon the security, the gas fees, and the performance of the chain. For example, I could choose the EVM chain of EVM shard of Near for high performance in terms of or low gas fees. If I want to do a high scalability, high performance, I can choose the core L1 layer. But if I also want to use Uniswap of the world on the Near blockchain operating system, I can still do it using a decentralized front end, choose the gateway or the smart contract layer of any of these chains, and also at the end say that I want to write it down on a Polygon or on EVM, any of the EVM chains, or on Solana, or even on the Near chain. So that's a different approach from the Near blockchain operating system. Instead of adding a lot of these blockchains next to each other, like in vertical, there's a horizontal layer that has been created on top of all of these chains. So also in terms of liquidity and asset mobility, like I said, if you have an interoperable system, you can easily move your tokens, your identities, and your information that are stored in IoT devices as well, right? When the 5G really kicks in, when you can easily transfer them across different chains, the whole transferability and the mobility of asset could be very easy. So there are also different research and advancements happening in the blockchain interoperability world. There are a lot of IoT-based solutions. There are a lot of AI-based solutions that are built with the core blockchain or with multiple blockchains. Near itself is trying something called as Near GPT, which is a part of the blockchain operating system that you can use to automate your tasks and perform a lot of the transactions with a simple if this then that scenarios. And a lot of these interoperability solutions are being built with different domains in mind. Like there are solutions that are built specifically for employees' productivity, like I mentioned with AI, automation, and blockchain, because that provides extra security. But also in terms of IoT systems with barcode, RFID chips, among others. So that's also a very interesting area that is impacting in terms of single source of truth, immutability, and finality of the solutions that we use across the chain. Yeah, so in the next slide, we are going to also see what I mentioned about the notable projects. So one, indeed, like I said, Polkadot, it has the multiple parachains that is very different in characteristics, all of them. But at the end of the day, they roll up and come back to the same Polkadot nomenclature or naming conventions to be able to write all the transactions and the transaction schemes on their finality layer. And it's also very focused at private, but as well as the public or the permissioned or non-permissioned blockchains, as we know. OneChain took a very nice initiative back in the day with a lot of multi-party computing, which is a very common feature on all blockchains today. But it also has a lot of digital transfer solutions across at least 12 chains that I know of. So Cosmos, with their Cosmos zones and hub, is also a very interesting use case. Wormhole started as a initiative of Cosmos, which solves a lot of these problems and takes a very unified approach to how do we solve the problems, such as how the Web3 was designed, what were the flaws in the design of the Web3, and how do we solve the flaws that exist today in the Web3 design. So the Cosmos takes a very different hub and zones approach, where there are different ways you can communicate with one chain while also use the same logic or different logic for multiple chains. While at the finality layer, they have something called as the Guardian network, which is managed not only by Cosmos, but it can be managed by any chain or any big independent body or a group of people, like a decentralized autonomous organization as well, being one of the Guardian validator network. So Near protocol, what we are trying to do at Near, like I mentioned, so we built this blockchain operating system, and it has taken a very different approach. Like I mentioned, it has the classic horizontal approach, try to keep adding one chain after the other. It has a wrapper, a very horizontal approach. So the wrapper is built on top of the L1 chain of Near, with which, like you can see on the slide, you can build the decentralized front end. A good example there is you are building a front-end component which can communicate with MetaMask, but it can also communicate with Near wallet. It can communicate with Trust wallet, or it can also communicate with any wallet that supports multiple chains. So using this decentralized front-end, which is completely open source, by the way, and can be built by anybody. It is not built by Near. So people are contributing to it. There are more than 10,000 components already built on blockchain operating system, more than 20,000 users on it. So what this does is it provides you the flexibility to choose after you have built the decentralized front end, whether you want to build a smart contract layer or an API gateway. So that's the second part, the gateway APIs. So what this gateway API does is it creates an extra middleware layer which is connected to the decentralized front end that you built, and it allows you to communicate with any of the chains under a layer under it, whether it is Polygon, whether it is Near, Solana, or Cosmos. And at the bottom layer, again, you can choose whether you want to write on any of these chains using the gateway, which is what we call as multi-chain finality. So you choose whether you want to write on one chain, or you can also choose to write the same transaction on multi-chain if you wish. And the two very outstanding features of the Near blockchain operating system is, one, it is designed to scale because it works across the stack. And second, it is optional for you to whether start with the front end, decentralized front end, or you start with the gateway APIs. You don't have to do it all. You can start from one over the other. We have a workshop tomorrow with some of our colleagues. If you want to see how that works in real action with code, I think we have a very interesting Uniswap working on Near, going through a gateway and writing the finality on the Near L1 chain. So if you get time tomorrow, please attend that workshop. It will be very, very interesting to see how this industry is moving forward in terms of interoperability in a true sense from a design perspective, because interoperability until now has always been addressed as a problem, and we have been solving the smaller part of the problem instead of looking at it holistically from a design perspective. So Near blockchain operating system really takes the design approach. It has been designed separate in a very different way so that it can be scaled, programmed, and be open source, given to the developers who can build different solutions that can be built by them instead of being built only by the L1 chain themselves. Yeah, those are my LinkedIn, GitHub, and Telegram accounts. That would be it from my end today. Thank you so much. If you have any questions, we still have 5 minutes.